Last time we looked at these three laws of logarithms. The law regarding multiplication, division, and raising to a power or index. Now, what we want to do is look at some results that come from the division law. So let's clean parts of the board, and then we're going to look at these results. Now, let me just make an adjustment here. We want to look at some results from these laws of indices. Now, suppose we have, for example, 3 raised to the power of 4, and it's divided by 3 raised to the power of 4. According to this law, the second one here, we should have 3 raised to the power of 4 minus 4, which is 3 raised to the power of 0. Now, if we have 4 raised to the power of 4 divided by 4 raised to the power of 4, then we should have 4 raised to the 4 minus 4, which is 4 to the 0. If we have 5 raised to the 4 plus 5 raised to the 4, then we should have 5 raised to the 4 minus 4, which is 5 to the 0. Right? Now let's look at these individually. What is 3 to the 4 divided by 3 to the 4? 3 to the 4 divided by 3 to the 4. When you cancel it, you get 1. Because a number divided by itself is 1. It should apply to this too, right? You have 4 raised to the 4 divided by 4 raised to the 4, which is 1, because it cancels itself. 5 raised to the 4 divided by 5 raised to the 4, you should get 1 because it cancels itself. Even if you have 5 raised to the 6 divided by 5 raised to the 6, this will be 5 to the 6 minus 6, which is 5 to the 0. 5 to the 6 over 5 to the 6, it cancels itself, so it should be 1. We seem to be getting something done here. Let us say you have a general number n, or say x raised to the power of a divided by x raised to the power of a. What you have is x raised to the a minus a, but then this is x raised to the 0, and by the arguments that we had here, x to the 0 is supposed to be 1. Basically, what it says is that when you have a number raised to the power of 0, the answer is 1. It's always 1. You could try it on a calculator too. Let me try it on my calculator here. I have a calculator here. Let's say 2. Let's start with 1. 1 raised to the power. My calculator have the x to the y on the button, but on the screen it says 1 and the caret. Alright, to the 0 equal, I get 1. Let's try 2 raised to the 0, I get 1. Let's try 5 raised to the power of 0 equal, I get 1. Let's try 100,000 raised to the power of 0. I get 1. Big number or small number, I get 1. If you're trying this on your calculator, you might happen to try -6 raised to the power of 0. What would you get here? You would see -1. When you're using the calculator, you have to be careful. What you have to do is put the -6 inside a bracket, and you get equal, or you get 1. Remember, when you have this -6 raised to the 0, what the calculator interpret is -1 multiplied by 6 to the 0, and it keeps the negative. So the answer you see is -1. You should have -6 raised to a power of, for example, 0. The negative number should be in bracket, right? It's like you have -6 to the power of 2. -6 squared is going to give you -36. What you should have is -6 in bracket squared, and you get +36. This -6 squared, the calculator would interpret it as -1 times 6 by 6, which is -36. So you have to be careful when using the calculator. But anyway, back to our argument here. You raise a number to the 0, you always get the answer as 1. So that's one important result you should remember. Please make a note of it. We're going to look at another result. Let's erase part of the board. This result will also come from the law that says if you raise a number to a power divided by a number raised to another power is same as the number to the numerator power minus the denominator power. The power in the numerator, that's at the top, minus the power in the denominator, which is at the bottom of the division, right? Suppose you have, for example, 5 raised to the power of 2 divided by 5 to the power of 1. What do you get? It should be 5 to the 2 minus 1. Suppose it's 5 to the 10 divided by 5 to the 9. What you should have is 5 to the 10 minus 9. In each case, in this case, you get 5 to the power of 1. In this case, you get 5 to the power of 1 just the same. Now, 5 to the 2 divided by 5 to the 1. What you would have is 5 by 5 divided by 5. And you cancel them, and you get 5. This is suggesting that 5 to the 1 is 5. Let's look at this. 5 to the 10 divided by 5 to the 9. Mean you have 10 5s up here divided by 9 5s down here. And when you cancel, you will have 9 5s. Take out 9 5s up here, and you have 1 more 5 remaining, showing that 5 to the 1 is 5. If you have, for example, another example, 5 to the 6 divided by 5 to the power of 5, it would be 6 5. They all multiply one another over 5 5s, and they all multiply one another. Then you cancel down. 5 cancel 5, 5 cancel 5, 5 cancel 5, 5 cancel 5, 5 cancel 5. you have only one 5 left. So 5 to the 6 divided by 5 to the 5, as is here, should amount to 5. So what is 5 to the 6 divided by 5 to the 5? Is 5 to the, according to this law, is 6 minus 5. It's supposed to be 5. But what is 5 to the 6 minus 5? It is 5 to the 1 is equal to 5. Now, you could try it with other numbers than 5, but I will guarantee you that it will work out that a number, any number you try, let's call it x because it can be any number, when you raise to the power of 1, the answer will be the number itself, x, whatever x is. So basically, when you raise a number to the index 1, you get back the number itself. Let's try it out on our calculator. Let's erase these things that we wrote before, and let's try that on our calculator here. We have 5 raised to the power of 1 equal, we get 5. Okay. 10 raised to the power of 1, we get 10, the same 10. 15 raised to the power of 1 is how much? 15. Interesting. What about 1000 raised to the power of 1? We get 1000, you know. Get the same 1000. Suppose we try negative 3 and negative 3 raised to the power of 1. What do we get? We get the same negative 3. 50,000 raised to the power of 1, we get the same 50,000. It seems we can't escape from it. This law holds, it is a valid law. You raise a number to the power of 1, you get back the number itself. Alright? So that is one. Those are two results that come from the laws of indices. In the next video, we'll look at some more results.